we form an equilateral pyramid. This is what's known as a tetrahedron. If we were to place another one of them identically at the bottom, it would form another of the Platonic solid shapes. So if we look at the tetrahedron, we have what are called segmented lines that are forming. Each face of the segmented lines have lines of symmetry within them. And this is what forms what's known as these perfect Platonic solid geometries. These geometries were originally first written down and understood by Plato, and later through his student Euclid did we come up with Euclidean geometry and the axioms in axiomatic geometry. And to get back into axiomatic geometry, what we understand is lines and how a line can segment a whole area. And when it's segmented, it forms somewhat of a polygonal triangle within itself. But that line continues to go on. And what happens when we form a line that hits it parallel? And what happens when we form a line that hits it perpendicular? Well, the rules say that when we form a line that's parallel, they don't intersect. And when we form lines that are perpendicular, they only intersect at one point. This is what's known as a parallel line postulate by Euclid geometries. This is understood well in basic shapes and basic solids. We'll stay on this geometry just for a quick minute to understand angles, understand perpendicular lines, and start to understand, circular arcs, circles. Put a circle through a 3-point. It was called a three-pointed circle. It's going to create a perfect circle within those 3 points. So that still gets into axiomatic geometry. And then we begin to form what's known as the sphere. The sphere is the first in the understanding of logic. So if we understand geometry as the fundamentals of logic, we see a sphere as unity. We see it as oneness. We see it as wholeness. It's completely equal on all sides. It's completely homogeneous in its strength, isometric. This is one of the most uniform, strongest shapes in the world. Now we can begin to break this apart. We can begin to segment it as we did the triangle. But when we do that, we begin to have to segment it circularly. Let's do that. Let's go ahead and add 3 points. Take a segment of this circle. And when we look at that, we begin to understand the geometry of a sphere versus a circle. Circle is the 2-dimension on a sphere. It's a topical plane of a flat 2-dimensional plane of geometry through a sphere. And just as a triangle is to a tetrahedron. So this pretty much gets into the basics. There's what's known as vectors. If I were to take an angle, shoot it through to another angle in a certain direction, so it has an arrow to it, that would be what's known as a vector.